Okay, so inverse relation. You can define an inverse relation for a binary relation R from a set A to set B. The inverse relation is a relation from set B to A, and you would have B related to A in the inverse relation if A and B were related in the original relation. Okay, you can do this always when you have a relation, a binary relation from A to B. Okay, you can define the same relation on the same set as well. Think of AB as the same set. Yeah, okay, so if R is an equivalence relation, is it true that R inverse is also an equivalence relation? This is a good question, I think. I want you guys to think about it and appreciate this question. Is it true that inverse of an equivalence relation is also an equivalence relation? This time no pens or papers, just think about it. Think of an example of an equivalence relation. हमने अभी देखी हैं 3-4. Try to construct their inverse relations in your brain and think, does it preserve reflexivity? Does it preserve symmetry? Does it preserve transitivity? Okay? Does anyone talk? Oh, yeah, Zoha wants to talk. So again, R के बारे में आप कुछ assume नहीं कर सकते कि R क्या. R के बारे में आप सिर्फ ये assume कर सकते हैं कि R is an equivalence relation, which means that it's reflexive, it's symmetric, and it's transitive. Okay? You want to talk? Yeah. So let's look at reflexivity. Okay? Let's assume that R is reflexive. So R inverse reflexive होगा? Okay. So if AA is there, so AA का जो reverse है, that's also AA. Okay? If AA was in the original relation, so AA नया relation में भी होगा. Okay? तो reflexivity preserve हो रही है. Okay? Symmetry भी preserve हो रही है.
A और B एक subset के अंदर है, तो B और A B उसी के अंदर होना चाहिए.
Yes.
अगर उससे विपरीत.
हाँ. So अगर A B और B A original relation में थे, तो नए relation में you would get B A and A B again as the reverse of the original relations. Okay? Transitivity. Okay, how?
A B B C A C.
हाँ.
जो C है वो A1 लेगा. ऐसा उल्टा चलता है.
क्या?
आपकी तरफ है.
क्या? This proof will not be accepted in the exam. Okay? The proof that I'm going to accept in the class, maybe वो slides पे हो, I don't know, but I'm gonna write it down for you here. So you're going to write down what you know, and you're going to write down what you want to prove. Okay? What do you know? You know that for all arbitrary A, B, C, A are B and B are A imply, sorry, तो मैं कुछ और बात कर रहा हूँ, सिमेट्री की बात शुरू कर दी है. B are C imply A are C. Okay, this is known to me. Okay, and this is my premise. This is what I want to get. Okay, what I want to get is that for all A, B, C, yeah, okay, so for all A, B, C, I wanted to rename the variables, but in any case, A R inverse B and B R inverse C is going to give me A R inverse C. Okay? Okay. After this line, I think so ये मेरी premise है, ये मेरी premise है, और ये मेरी premise है. Okay? इस premise को मैं rename करूँगा क्योंकि यहाँ पे for all है तो I can pick any arbitrary A, B, C. Okay? So this is known to me. So if A R inverse is in my relation, तो फिर मेरे पास I must have B R A in the original relation, है ना? This is the definition of R inverse. By definition of R inverse. Okay. Also, I would have, if I have B R inverse C, so I must have C R inverse B, है ना? By definition of again R inverse. Okay. Okay. So by this premise, if sorry, I want yeah. Okay. Okay. So if CR B is there and BR A is there, this implies कि मेरे पास CR A था in the original relation, है ना? By definition of what was it? Transitivity, है ना? In R. R हमारे पास equivalence relation है तो R transitive ही होगा. Okay? So if this is the case, तो मेरे पास CRA था original. Okay? So force says that CRA implies I have AR inverse C. है ना? By definition of R inverse. And that's it. That's QED. This is what I wanted. You know?